Okay, 5.4, we're going to be solving radical equations. Okay, so radical equations are equations with variables in the radicand. So this right here, there's an x inside the radical. Radical equations may produce extraneous solutions. Extraneous solutions are extra solutions. That means we solved correctly, and for some reason we ended up with extra answers that don't actually work. Because this can happen, we have to check our answers to make sure they're valid answers. So we're going to practice checking first before we start to solve. Okay, so for example 1, it says check the solution for the radical equation. So it tells me that x is 6. This is the equation I solved for, so I'm going to plug 6 in and see if it equals what it's supposed to. Okay, so I'm not solving, I'm plugging it in. So x is 6, so 2 times 6 plus 13. Be really careful with your radical. It ends at the 13 and then it has a minus 1 and it equals to 4. I'm going to keep going. What is that? 12 plus 13. 12 plus 13 is the square root of 25. The square root of 25 is 5. And then 5 minus 1 does equal 4. So that's a good answer. Okay, let's try the next one. B, it says the square root of x plus 7 equals 5 plus x. X is 2. Okay, so I'm going to plug x is 2 everywhere I see the x value. So x. So 2 plus 7 equals 5 plus 2. Okay, so what do I get? The square root of 9 is equal to 7. 3 equals 7. Nope, that one doesn't work. Okay, let's try a third root. For C, the third root of 2x minus 1 is equal to the third root of x plus 6, and they're telling me x equals 7. So I'm going to plug it in, and then we just see what happens. 2x minus 1 equals the third root of x plus 6. Okay, and let me figure out each of the sides. 14 minus 1, which is the third root of 13. I don't know the third root of 13. Okay, let's try the right side. 7 plus 6 is the third root of 13. Oh, I don't know what the third root of 13 is, but those match. So x equals 7 is a good answer. Let's do one more checking. For D, it's x plus 30 raised to the 1/2 equals x. So let's plug in negative 5. So where x is negative 5 plus 30 raised to the 1/2 equals x. X is negative 5. Okay, so negative 5 plus, that's 25 to the 1/2. What's 25 to the 1/2? That's the square root of 25. Okay, what's the square root of 25? It's 5. Does that equal negative 5? Nope. Okay, so x equals negative 5 is actually not a solution to this equation. If I had found it as a solution, it still doesn't work. Okay, now let's actually solve some radical equations. Okay, to solve a radical equation, first thing we do is we isolate the radical. That's the square root part. Then we raise each side of the equation to the power that matches the index. Solve it, check for extraneous solutions. Okay, so let's look at A. Here's the square root. The square root, the radical is only the part that has a square root symbol on it. So this part needs to be isolated. Okay, so let me add the 3 over so I can isolate the radical. So I have the square root of x equals 10. Okay, I'm going to rewrite this just for notes. Okay, I need to raise each side of the equation to the power that matches the index. Since this is a square root, I need to raise this to the second power. Okay, the squared and the square root cancel each other. So I get x equals 10 to the second power is 100. Okay, now I need to check and see if it works, because even though I solved it correctly, it's entirely possible that my answer is still wrong. Okay, so if I check it in the original equation, I have the square root of x. What's x? 100. If I minus 3, I should get 7. So square root of 100 is 10. 10 minus 3 is 7. that works. So I'm going to go ahead and box my answer. Okay, and eventually you'll get faster at checking. You should check, but we'll hopefully get better at checking it in our heads. Let's try another one. Okay, we need to isolate the radical. The radical is the part with the root. So in this case, the radical is this whole piece. Well, it's already by itself on its side of the equation, so we can go ahead and cancel it. Since it's a square root, I'm going to square both sides. If I square a square root, the squared and the square root cancel. So I bring down the 5x plus 1 equals, what's 6 to the second? 36. Okay, what's the next step? Solve. Let's solve it. 5x equals 35. Divide by 5. Okay, I get x equals 7. Okay, now probably it works, but we have to check because square roots produce extraneous solutions. Okay, so in the original equation, I have 5 times x plus 1, and it's supposed to equal to 6. What is that? 35 plus 1? 35 plus 1 is square root of 36. Does that equal 6? Oh, it does. Since it works, I'm going to go ahead and box it. It's a valid answer. Okay, let's try some more. Okay, C, 2 times the square root of x plus 2 equals 8. Okay, the square root is what I'm trying to isolate. That's this whole piece, which means I don't want the 2 there. So I'm going to go ahead and divide by 2. I'm just rewriting for notes. Okay, I isolated the radical. Since this is a square root, to cancel a square root, I square both sides. The squared and the square root cancel. And then 4 to the second power is 16. And then I'll go ahead and minus the 2 over. So I get x is 14. Okay, let me check that it works. I'm doing CK for check, by the way. Okay, so 2 times x plus 2 equals 8. 2 times the square root. What's 14 plus 2? 16? What's the square root of 16? Just 2 times 4 equal 8? Yeah, it does. So that was a good answer. Okay, ready for D? Okay, D says the third root of x plus 9 equals 4. So here's my radical. That's what I want to isolate. Everything involving the radical. So I do need to move the 9 over. Okay, I'm going to rewrite this step for notes, but you don't have to. Okay, now be careful. This is a third root of x, so the index is 3. If it's a third root, to cancel the third root, I have to raise it to the third power. Okay, the third root and the third power cancel. And what's negative 5 to the third? Negative 125. Okay, let me check it. Okay, third root of negative 125 plus 9 equals 4. What's the third root of negative 125? Well, it's negative 5 plus 9. Does that equal 4? Yep. Okay, and most of the time they're going to check today. They're not going to all check tomorrow, which is why I'm trying to get you in the habit of checking. Okay, let's try a couple more. Okay, we need to isolate the radical. This is the radical. So that minus 1 should not be here. Let's get rid of it. Okay, we're doing a third root of 2x minus 9, so I need to raise this to the third power. What's 3 to the third? 27? Okay, let's go ahead and solve it. Let's see, if I add 9, I get 36. If I divide 2, I get 18. Okay, let's check it real quick. The third root of 2 times 18 minus 9, and then be careful, and then I minus 1, and it should equal 2. So what is that? 36 minus 9 is 27. What's the third root of 27? 3 minus 1 is 2. Yeah, that works. So x is 18 is a valid answer. Okay, F. Where's my radical? Here's my radical. I need to get rid of that 5 in the front. Okay, since it's a third root, I'm going to raise it to the third. One times 1 is 1. Okay, if I minus the 3, I get x equals -3. Okay, let me plug it back in my little CK check. 5 times the third root of x plus 4 equals 5. So 5 times the third root of 1 equals 5. What's the third root of 1? 1. 5 times 1 is 5. Yep, it sure is. Okay, let's do 2 more. Okay, G, where's my radical? There's my radical. I got to cancel the 3 and the -7, so let me add the 7 over. Okay, what now? Divide the 3. Let's divide the 3. Okay, the square root of x plus 6 equals 4. Since it's a square root, we're going to square both sides. X plus 6 equals 4 times 4, 16. Okay, if I minus the 6, I get 10. Let's check it. Okay, 3 times x plus 6, and the square root ends, and then there's a -7, and this should equal to 5. 10 plus 6 is 16. 3 times, square root of 16 is 4, so 3 times 4 minus 7. 3 times 4, 12 minus 7 equals 5. 12 minus 7 does equal 5. Amazing. Okay, one more. Okay, where's my radical? Here's my radical. Let's minus the 8 over. Okay, 3 minus 8 is -5. Okay, since it's a square root, I'm going to square both sides. You do not have to rewrite this step. I'm doing it for notes. Okay, when you square a negative, you do need to put it in parentheses. I do it for all the numbers, but you have to do it for negatives. Because I'm squaring the negative. -5 times -5 is +25. If you don't put parentheses, you're not squaring the negative. Okay, I'm going to minus the 4, and I'm going to get x equals 21. Okay, let's plug it in and check. Okay, so 21 plus 4 plus 8 equals 3. So the square root of 25 plus 8 is 3. Hold on. So 5 plus 8 is 3. No, 5 plus 8 is not 3. Okay, so finally we get to 1 where the answer we got did not work. So we got that x equals 21, but then we also got that 21 does not work, so x actually cannot equal 21. But that's the only answer we got was 21. And I just said x can't be 21, so what's the answer? No solution. Okay, I checked it, and that's how I found out there was no solution. I can show you what step would have also told me it was no solution. When I got to this step right here, I was saying when I square root something, I'm going to get a negative answer, which is never true. If I do a square root, I will never get a negative answer. If I do a cube root, I might, but a square root will never give me a negative answer.